Very good morning. Let us start with the topic called geometry. Altogether, there are 6 areas at geometry. First one is lines, angles, and polygons. And second one, triangles. Third one, quadrilaterals. Fourth one, circles. Fifth one, solid geometry. And sixth one, coordinate geometry. These are the 6 areas which provide solid foundation for the geometrical concepts which have been appearing in the foundation IIT things and the main IIT curriculum also. So let us start up with lines, angles, and polygons. Most of the students, while they are trying to learn the basic fundamental concepts of lines, angles, and polygons, what they try to do is they try to by heart the concepts. So that's the reason they are not able to apply the same concepts logically when they proceed for the further chapters or the advanced chapters. So let us try to learn this concept in a logical way. Try to consider two parallel lines like a railway track. A line which is intersecting these two parallel lines is called a transversal. Once again, I'm repeating it. A line which is intersecting two parallel lines is called a transversal. If the same line intersects one parallel line, then it is not called a transversal. Whenever transversal is there, we can observe there will be 8 angles. It's not necessary that these 8 angles should be in the same order. Now, after pointing out the 8 angles, now we talk about the positions of the angles. That means angle 1 is positioned at which place, angle 3 is positioned at which place, like this. For all the angles, we'll be deciding the positions. Generally, these positions are based on the directions of the lines. If you can observe at the diagram, there are 3 lines in this figure. 2 lines are parallel lines, and third one is transversal. In order to identify the directions, for example, let us consider angle 1. With respect to the parallel line, this angle is on the top side. So, with respect to the parallel line, angle 4 is on the bottom side. That means there are 2 directions existing. With respect to a parallel line, either an angle can be at the top side or an angle can be at the bottom side. So, the 2 directions for the parallel line are top or bottom. In the same fashion, with respect to the transversal, the angles can appear either on the left hand side or they can appear either on the right hand side. So, the 2 directions are either left or right. Now, based on these directions, let us decide the positions of the angles. For example, consider angle 1. Yes. With respect to the parallel line, it is on the top side. So, it is top. And with respect to the transversal, it is on the right side. So, its direction is top right. And this one, it is on the bottom side and right side. So, its position is bottom right. Similarly, let us figure out the positions of all the angles. This is again top right. This is bottom right. This is top left, bottom left, bottom left, top left. After deciding the positions of all the 8 angles in this fashion, now we proceed with classification of angles. The first classification is corresponding angles. Now, to put this definition in a very simple way, any 2 angles, if you can observe this figure, any 2 angles which have the same positions are called corresponding angles. For example, you can see the position of 1 is top right, the position of 5 is top right. That means these two angles have the same positions. So they are called corresponding angles. So the definition is angles with same positions are called corresponding angles, and they're always equal. Let us see how many pairs are there. 1, 5, angle 1 is equal to angle 5, and 4 and 8, angle 4 is equal to angle 8. Next one, 2 and 6, 2, 6, and the last one, 3 and 7. The second classification comes interior angles. In the word itself, you can see the interior, which means inside. If you consider two parallel lines, the angles which are inside the parallel lines are called interior angles. Those four angles are 3, 4, 5, 6 because these four angles are inside or within the parallel lines. So I can say angle 3, angle 4, angle 5, angle 6. These four are interior angles. And the third one, exterior angles. Exterior angles means angles which are outside of the parallel lines. If you consider this parallel line, there are two angles which are outside 1 and 2, and this parallel line, two angles outside again 7 and 8. So angle 1, angle 2, angle 7, and angle 8. These are the first three classifications. Let us move on to the fourth and fifth classifications. Fourth one, alternate angles. Alternate angles has got another name, which is called interior opposite angles. In the other name itself, you can observe that there are two important words, interior as well as opposite. Interior means whatever the two angles you are trying to pick up, those two angles should be first interior, and on the interior side, they should be what? Opposite. So here, if you can look at the figure, there are four interior angles, and those four interior angles, the opposite angles are 3, 5, 4, and 6. So angle 3 is equal to angle 5, angle 4 is equal to angle 6. The fifth one, vertically opposite angles. In order to say that two angles are vertically opposite, they should satisfy two conditions. First condition is both the angles should be opposite. And second condition is whatever the two angles you are trying to pick up, out of those two angles, one should be interior and the other one should be exterior. Now let us see an example here. If you take 1 and 3, these two are opposite. That means the first condition is verified over there. And 1 is exterior and 3 is interior. That means the second condition is also verified. So we can say that 1 and 3 are vertically opposite angles and they are equal. So angle 1 is equal to angle 3, angle 2 is equal to angle 4, angle 5 is equal to angle 7, angle 6 is equal to angle 8. This completes the concept of all the classification of the angles which are in phi. Now, by taking these concepts into the consideration, let us try to take up an example. Consider two parallel lines L and M. Let us name these angles as X, Y, and Z. The question is, if L is parallel to M, then find the relation between the three angles X, Y, and Z. This is the question. Now, if you can observe the given diagram, just memorizing the concepts which I have already taught, what is the definition of a transversal which I given for you? Any line which intersects two parallel lines is called a transversal. Whereas if you can look at this figure, if you consider this line, this is not intersecting two parallel lines, whereas it is intersecting only the first one. That means I cannot say this is a transversal. And if you can see this one, even this line is not intersecting two parallel lines, it is intersecting only this one. That means even this is not a transversal. That means in the given figure, there is no transversal. When there is no transversal, we cannot talk anything about the relationship of the angles. So now what we will be trying to do is, we will try to extend this line so that it will come and intersect the second parallel line also. Now if you can see it, this one, now it is intersecting both the parallel lines. So now I have the liberty to call it as transversal. Now as the transversal is there, let us see what we can talk about the angles. Based on the positions, what is the position of X here? It's on the top side, it's on the right side. So let us name it as top right position. And similarly, if you can take this position, even this position is on the top side and on the right side. So I can call this as top right. Now, these two angles have the same positions, and angles with same positions are called corresponding angles, and they are always equal. So when this is X, obviously this has to be X. Now this part, angle on a straight line is 180 degrees. That means this total angle is 180, in which this part is Y. So obviously this part will be 180 minus Y. Now if you can look at these two angles are opposite, and Z is exterior and this angle is interior. That means both the conditions are satisfied, and these two conditions lie in vertical opposite angles, and vertical opposite angles are always equal. So when this is Z, even this happens to be Z. Now if you can observe this small triangle over here, in this triangle all the three angles we got it, and sum of the three angles in a triangle is always 180. So the first angle is 180 minus Y, second angle is X, third angle is Z. The sum of these three angles should be equal to 180. 180 and 180 will get cancelled on both the sides. Try to take minus Y that side. Thus will give you X plus Z is equal to Y, which is the required relationship between the three angles. Now, let us try to see how we can do the same method, same problem in another way. Before switching on to the other method, in this problem, what we have done is, in the given problem, as the transversal was not there, we have created a transversal and then we have proceeded. So let us name this as creating a transversal. Now let us start with the alternate method. Trying to take the same diagram here. Now, in this figure, there are two parallel lines. With respect to these two parallel lines, try to take another parallel line like this in the middle. Now altogether, there are three parallel lines now. Let us name these three parallel lines as 1, 2, and 3. Let us consider the first two parallel lines, 1 and 2. This 1 and 2 parallel lines are being intersected by this line. So I can call this as transversal 1. Now the positions of X are top right, and this particular angle position is also top right. So these two positions are same. So when this is X, even this happens to be X. Now consider the second and third parallel lines. Second and third parallel lines are intersected by this line. So I can call this line as transversal 2. Now after considering this, the position of Z is bottom right, and even this position is bottom right. So when this is Z, even this happens to be Z. So according to our analysis, this total angle is X plus Z. But according to the given problem, this total angle is what? Y. So obviously Y is equal to X plus Z, which is the required relationship between the three angles. In this method, what we have done is, we have created a parallel line. So This method is called creating a parallel line. Now, the next topic is polygons. Can anyone define what is meant by a polygon? Because most of the students have habituated to by heart the concepts and definitions. But originally, how the concept of polygon has been introduced. For example, I give you a small dot here. Let us say this one. And I'm asking you, with the help of how many lines you can close this? Can you close this with the help of one line? No, obviously not. With the help of two lines, can you close it? No. But with the help of three lines, you can close this. So that this has become a closed surface, closed region. Now, the same dot, with the help of four lines also we can close it. With the help of five lines also we can close it. That means in order to close a region, minimum you require three lines, three or more than three lines. So the definition of a polygon is a closed region with three or more than three lines is called polygon. Now, based on the number of sides of a polygon, polygon classification has been done. Let us say that the number of sides in the polygon, let us name it as n, and here the polygon. If a polygon has three sides, we call it as triangle. Four sides, quadrilateral. Five sides, pentagon. Six sides, hexagon. Seven sides, heptagon. Eight sides, octagon. Nine sides, nonagon. 10 sides, decagon. This is how the classification has been done. Now, like this, we try to learn the fundamental concepts in a logical way, and switching on to triangles and squares also. What is the fundamental property to form a triangle? People generally doesn't have an idea about the fundamental concepts of the triangles, because basically they know all the important formulas. For example, like some of the three angles in a triangle is 180. In an equilateral triangle, all the sides are equal. In isosceles triangle, two sides are equal. These are the very famous concepts, and the reason students always know it. But in order to form any kind of a triangle, what is the minimum requirement? The minimum requirement is sum of any two sides is greater than third side, and difference of any two sides is always less than third side. Now, based on this concept, let us try to take an example. Let us say 1, 2, 3. And I'm asking a question: with the help of these three numbers, can you form a triangle? No, we cannot. The reason is the first concept, sum of any two sides should be greater than the third side. Let us take the combination of two sides. The combinations are 1 plus 2, 2 plus 3, and 1 plus 3. Now, based on this formula, all these combination of two sides should be greater than the remaining third side. Here, the remaining third side is 3. Here, the remaining third side is 1. Here, the remaining third side is 2. Whereas these two are true, because 5 is greater than 1, 4 is greater than 2, but here 3 is not greater than 3. So, here, out of the three combination, one combination did not work out. So, using these three numbers, we cannot form a triangle. Let us take another example: 2, 3, 4. 2 plus 3, 3 plus 4, and 2 plus 4. This is greater than 4, this is greater than 2, and this is greater than 3. Here you can observe 5 is greater than 4, 7 is greater than 2, and 6 is greater than 3. All the three are satisfied. That means using these three numbers, we can form a triangle. Now, And another important concept of triangle, if you consider a triangle in this way, let us name it as ABC. In any triangle, if two sides are equal, then their opposite angles are also equal. And this is a vice versa formula, which means if two sides are equal, their opposite angles are equal. If two angles are equal, their opposite sides are equal, either way. And another concept, if you consider a right angle triangle, the side opposite to 90 degrees is called hypotenuse. This is hypotenuse, and this is opposite side, and this is adjacent side. Now, based on the Pythagoras theorem, hypotenuse square is equal to opposite square plus adjacent square. Students are very familiar with this formula, but they don't try to look into the logics of the concept. For example, after telling this concept, if I ask the students to work out this problem, let us say that this is 48 and this is 64, and try to find out what is hypotenuse. Now, in order to find out the hypotenuse, students right away switch on to this Pythagoras theorem. There's no doubt about it. Hypotenuse square is equal to 48 square plus 64 square. Now, in order to work out this or to calculate this 48 square, they will be taking some 1 minute time. And in order to calculate the 64 square, again they will be taking 1 minute time. So altogether, after getting this again, in order to find out the square root, another 1 minute. So altogether, they will be taking 3 minutes to 4 minutes time in order to solve this very simple thing. But in order to avoid this, in order to save time, let us look into the logics of the Pythagoras theorem. We can call a triangle as a right angle triangle only if the triangle sides satisfy this property. That means, for example, you take 3, 4, 5. 3, 4, and 5 satisfies this Pythagorean property, like 5 square is equal to 3 square plus 4 square. Now, 5, 12, 13. Another set of 3 numbers, which is 13 square is equal to 5 square plus 12 square. You can observe that using the first set of 3 numbers, we can form a right triangle. And using the second set of 3 numbers also, we can draw a right angle triangle, because these two are satisfying the Pythagorean property. That's the reason we call these numbers or sets as Pythagorean triplets. These are called Pythagorean triplets. The greatness of this triplets is, in this triplet number, if 2 numbers are there, automatically the third number has to be the existing one itself. That means he has given 3 and 5, automatically the third one has to be 4. He has given 5 and 12, automatically the third one has to be 13. That means in the set of these 3 numbers, if 2 numbers are being given, there's no need to think and to solve it. The third number has to be the here existing one. Now, based on this concept, let us look at the example which I was discussing earlier. Here, opposite side has been given as 48. You can write down 48 as how much? 3 into 16. And you can write down 64 as how much? 4 into 16. In these two, what is the common number here? 16. So when these two have the same common number, obviously the third side should also have the same common number. Now here in the opposite side, what is the number? Remaining number 3. And here, what is the remaining number? 4. In the Pythagorean triplet, along with the 3 and 4, what is the third number here? 5. So here it is 5 into 16. Obviously, answer is 80. So without the help of squaring, without the help of finding out the square root, directly we came to know that the hypotenuse is 80. This kind of doing the mathematical problems is going out of the box and thinking it in a logical way and try to do it. Because students, when they get habituated in doing the mathematical problems in such a logical way from the basic concept itself, then the advanced concepts will become a cakewalk for them. Because you take any competitive examination, the problems which are being designed for the competitive examinations are based on one or the other kind of logic. If all the problems are very tedious, very lengthy, obviously the given time would not be sufficient. That means there should be some logic which is hidden in the problems. Try to find out that logic. Once you get that logic, believe me, any kind of a problem will become more easy for you. Thank you.